Welcome to the 5th session on ionic equilibria, in which we will be dealing with ionic product of water, pH scale and pOH scale. Ionic product of water is for taking the molar concentrations of the ions produced by the ionization of water, and pH and pOH, they are the scales to measure the hydrogen ion concentration as well as the OH minus ions in a solution. So, let us see what is ionic product of water first. We know that water can undergo self ionization, or you can call it as auto ionization, in which one of the water molecule donates its proton to the other water molecule, forming an H3O plus ion, and this water molecule, after donating the H plus ion, changes to OH minus ion. Now, you can see that there is an equilibrium existing between the unionized water molecule and ionized one, or I can just put it as ions. These are the ions formed from it. Now, here exists an equilibrium, and it is a dynamic equilibrium because water will be ionizing, at the same time the ions will be combining to form back water. Now, since this is an equilibrium, you can apply the equilibrium law to this. So, what I am going to do is I am going to put an equilibrium equation for this, that is K is equal to product of molar concentration of hydronium ion to product of molar concentration of OH minus ions whole divided by the reactance is water molecule, and you have 2 water molecule, and therefore, that is square. Now, this is a constant at a given temperature because there is an equilibrium constant. Now, we know that water is only very weakly ionized. So, I can consider the concentration of water to be a constant. Now, I take this to this side because we put the 2 constants on one side, that is concentration of H2O square. This is taken as another constant Kw, that is a ionic product of water, that is equal to concentration of H3O plus into concentration of OH minus. I told you this is just an equilibrium constant, and therefore, the values will be constant so far as the temperature is constant. Once we change the temperature, the value of constant changes. Now, here if it is the case, you can see that if in any case, if in a solution, if the concentration of H3O plus is increasing, what will happen? The concentration of OH minus ion has to decrease, so as to maintain this as a constant at a given temperature. In a similar way, if OH minus ions concentration is increasing in a solution, normally to compensate that, the H3O plus ion concentration decreases, so that Kw will be a constant. So, far as the temperature is constant, that will be a constant. Now, we will see the definition for ionic product of water. Ionic product of water at a given temperature is defined as the product of molar concentration of H3O plus ions and OH minus ions at that given temperature. So, it is very important the temperature should be constant, and it has been found that for water at 298 Kelvin, ionic product of water is equal to 1 into 10 to the power minus 14, and this is considered as constant. And since it is a product of molar concentration of H plus ions and OH minus ions, that is usually we write the concentration as moles per liter, and you have that for both hydronium ion and OH minus ions, and therefore, the unit will be mole raised to 2 and liter raised to minus 2. that will be the unit. Now, what we are going to do is we are going to take the negative logarithm in both sides, because we know that ionic product of water Kw is H3O plus into concentration of OH minus. Now, I am going to take negative logarithm on both sides. It becomes minus of log Kw is equal to minus of log H plus, or you can put it as it is a hydrated form, that is only difference, concentration of H3O plus plus minus of log OH minus. Now, negative logarithm to the base 10 is always denoted by a subscript small letter p, and if it is for hydrogen we put it as pH, if it is for OH we put it as pOH, and if it is for negative logarithm of Kw just put p and write Kw. So, that is how we represent it. Therefore, here negative log of Kw can be taken as pKw and that of pH, and for OH pOH. Now, since Kw is constant, pKw will also be a constant, and pH and pOH values vary accordingly, so that the value of pKw is kept constant until unless the temperature is changed. Now, I told you there is a value of Kw is 10 to the power minus 14. So, minus log 10 to the power minus 14 is equal to pH plus pOH. This will be minus, this is the power of the log. So, minus of minus 14 log 10 will be equal to pH plus pOH. Here this becomes positive, log 10 equals 1, or you can put it as 14 is equal to pH plus pOH. For water, H3O plus concentration will be equal to molar concentration of OH minus, because water is neutral. There is no excess of positive ions or negative ions, and therefore, we can say that concentration of H3O plus square is equal to 10 to the power minus 14, or the concentration of H3O plus will be equal to root of 10 to the power minus 14, that will be minus 7. So much moles per liter. Now, this will be the same as for OH minus ions too. So, here we can say that for a neutral solution, the pH will be 7, pOH will be 7. If it is acidic, here the pH will be less than 7 and pOH will be greater than 7. So, that the total makes it 14. We will go into detail in the next topic. Next, we are going for the pH scale. We know that the number of ions present, or you can say the concentration of H plus ions in a solution determines the pH of the solution, and pH, as I have told you, it is a negative logarithm to base 10 of concentration of H plus ions. One more thing, usually to be perfectly 100% theoretical, instead of concentration we have to take activities. So, pH of a solution is defined as the negative logarithm to base 10 of any solution of the activity of hydrogen ions. So, instead of concentration, actually to be perfectly theoretical, it is considered as activity of hydrogen ions, but if we are considering weak solutions, you can replace their activities by molar concentration, and therefore, pH of a solution is defined as negative logarithm to the base 10 of the value of hydronium ion the concentration in moles per liter, or you can call it as hydronium or hydrated hydrogen ions, both are same. So, I can represent pH as an expression like minus log to the base 10 of H3O plus to be more accurate, or it can be, in some books you can find it as H plus itself, is equal to pH. Now, suppose I am having a solution of HCl whose concentration is 10 to the power minus 1 molar. How will you find its pH? What we have to take is, we have to take the negative logarithm to the base 10 of 10 to the power minus 1, and that will give you the pH. So, pH is equal to, this is the power of 10 in the log, and therefore, it becomes minus of minus 1 into log 10. Log 10 is equal to 1, minus of minus, the answer is pH is equal to 1. Here what you have to be very careful is, in the case of HCl it is okay, because we know that HCl dissociates to give H3O plus Cl minus. Here if I take 1 mole of HCl, you will get 1 mole of H3O plus ion. If I take 2 moles, you will get the same number of H plus ions. So, in that case we can directly write that as the concentration of H plus ions. Now, if I am taking another acid, let that be sulfuric acid. Sulfuric acid ionizes, let me include the water molecule too. So, we need not consider the concentration of water molecule, it gives H3O plus, and here actually sulfuric acid is capable of donating 2 H plus ions, and therefore, I am going to write it in a single step. So, I put it as 2 H2O, and each water molecule will take 1 H plus ion, giving 2 moles of H3O plus and 1 sulphate ion will be released. Now, if here I take 1 mole of sulfuric acid, I will be getting 2 moles of hydronium ions. So, here if I take 2 moles, you will get 4 moles, or you can say, that is, the concentration of hydronium ions in the case of sulfuric acid is twice the concentration of the acid taken. So, in that case, here if you have to find out the pH, you will have to take 2 into concentration of H3O plus. Got it? I think it is clear. So, first of all, you will have to check like how many moles of hydronium ion will be produced when an acid is ionized, and then only you should calculate the pH of that solution. Next is pOH. So, same as that in a hydronium ion, instead of hydronium ion, we will be taking the concentration of OH minus ion, that is the hydroxyl ions. The pOH of a solution is defined as negative logarithm to the base 10 of the value of hydroxide ion, concentration in moles per liter. So, what I am going to do is take the negative logarithm of hydroxyl ions concentration to the base 10. LOG stands for base 10, still I am putting it as to the base 10, will give you pOH. Instead of pH, you are putting it as pOH, because this is the negative logarithm of molar concentrations of OH minus ions in a solution. Again, in this case too, just like in acid, we will have to take the molar concentration of OH minus ions given out from an alkali. That is, if I am taking calcium hydroxide for example. Calcium hydroxide will ionize as Ca2 plus 2 OH minus ions. So, if I start with 1 mole, you will be getting 2 moles of hydroxyl ions. So, first we will have to consider that, and then you find out the concentration of OH minus ions, make it negative logarithm to base 10 of that concentration, and that will give you the concentration of pOH. Now, let us go for the problems. Calculate the pH of 0.02 normal nitric acid. Here we are asked to find out the concentration of 0.02 normal nitric acid. This is slightly different, because here we know that nitric acid dissociates as, I will put it here, plus water gives H3O plus NO3 minus. Now, in this case you can see whatever the concentration you have with nitric acid, same will be the concentration of hydronium ion. Now, again here they have given 0.02 normal. Now, what is the difference between normality and molarity? Normality is number of equivalents and molarity is number of moles. So, when I say it is normal, here we have to notice the difference between these two, and we have to give to find out pH. It is not the normality, pH is equal to negative logarithm to base 10 of the molar concentration, that is we need the molarity, not the normality. So, now let us see, that is normality of an acid is equal to molecular mass of that acid divided by basicity. Now, what is basicity? Basicity is number of replaceable hydrogen atom, and in this case it has got only 1, and therefore, the basicity is 1, and normality and molarity are the same, because there is no difference in equivalent mass or molar mass. So, we can say that, so for normality we have been taking normality is, we can say it is in terms of equivalent mass, both are same. So, in this case normality and molarity are same. So, you can take this as this is equal to 0.02 molar nitric acid. Now, nitric acid dissociates, whatever is the concentration of nitric acid, the same will be the concentration of H3O plus, and therefore, pH of the solution is equal to minus of log. What is the concentration of this? That is equal to 0.02, and the answer will be, and the way to take it, you take give negative sign, press log key, and in bracket give the value 0.02 in a scientific calculator, and that will give you the answer as 1.698, and that will be the pH. And we can see that the value is less than 7, pH is less than 7, which means that this is acidic. For neutral solution it is 7, when it is less than 7 that will be acidic, if it is greater than 7 that will be basic. So, we will go on for the next problem. Calculate the pH of 0.03 normal sulfuric acid. Here it is slightly different, and 0.03 molar sulfuric acid, and they have given the hint equivalent mass of sulfuric acid is equal to molar mass divided by 2, which is the basicity, or you can say number of replaceable hydrogen atom. Here we have 2, so that molar mass by 2. Now, let us see how we will do that. So, we are taking the first part, in which it is given that concentration of sulfuric acid is equal to 0.03 normal. I will write the ionization of sulfuric acid like this: H2SO4 plus water. It requires 2 molecules of water because there is 2 replaceable hydrogen atoms. You will get 2 moles of H3O plus SO4 2 minus. Again, if I take 1 mole, you will get 2 moles of hydronium ions. So, whatever is the concentration of sulfuric acid, double will be the concentration of H3O plus ions. Now, in this case they have taken the normality. Now, normality will not be equal to molarity. In this case it is different, because equivalent mass and molar mass, you take molar mass by 2, that is 1 molar mass is equal to 2 equivalents, and therefore, you can say that the normality will be twice the molarity, because molarity you have a greater mass, and for equivalent mass it is smaller value, and therefore, normality value will be higher. So, that will be twice its molarity. Now, molarity will be equal to normality by 2. Okay. Now, in this case, this is the normality. Therefore, the concentration of H3O plus ions will be equal to 0.03 equivalents per liter. Am I right? Because that is the equivalent mass. But here, since it is sulfuric acid, what will be the case? It should be twice. Whatever be, if I am taking 1 equivalent here, you will get 2 equivalents of H3O plus. So, in the case of sulfuric acid, this will be twice the equivalent mass. Now, I have to convert this into molarity. Molarity will be equal to normality by 2, which is equal to 2 into 0.03 divided by again 2. Okay. Now, we can do the pH. pH is equal to negative logarithm of 0.03, and the value was found to be 1.5229. Telling you once more, put a negative sign, press the log key and give the value 0.03 in brackets, it will give you the answer as 1.5299. Now, the other case, that is the B part. Here the concentration of sulfuric acid is 0.03 molar, that is the difference. Now, concentration of H3O plus will be again twice into 0.03. Why? Because if you take 1 mole, you are going to get 2 moles of H3O plus ions. So, the concentration of H3O plus ions will be 2 into 0.03, and here the concentration is moles per liter. You need not convert it. Now, this is pH is equal to minus of log 2 into 0.03, and if you calculate it, you will get the value as 1.2218. So, that is the difference. Okay. When you take molarity and normality, it will be different in the case of dibasic. Again, if you have tribasic, it will be thrice, and all that should be taken into account. Next problem is calculate the pH of 0.5 molar hydrochloric acid, which is only 90% ionized. It is not 100% ionized. Now, we know that concentration of H3O plus should be equal to 0.05 if it is 100% ionized. In this case, it is not 100% ionized, and therefore, the concentration will be only 90% of it, right, and that will be, let it be the value is 10, that is equal to 1.5 into 9 by 10. Let that value remain as such. Now, what we do is we have to find out the pH, and we know that HCl, the concentration of HCl plus water, it is not a dibasic acid, and therefore, it will give only one H3O plus ion, and concentration of HCl is equal to concentration of H3O plus ions. So, pH is equal to negative logarithm to the base 10 of concentration of H3O plus, that is 0.5 into 9 by 10, and if you take the logarithm of that negative logarithm, the value becomes 0.3468. So, again, when the ionization is only partial, we have to convert that the concentration into that percentage. Only so much of ions will be available, and that value represents the pH. Next is calculate the pH of 0.001 molar NaOH. Here you have to be very careful. NaOH on ionization does not give any H3O plus ions. Now, how will we find out the pH? We know that pH plus pOH, that is a negative logarithm of hydrogen ions, and OH minus ion should be equal to 14. So, once we find out the value of pOH, that is what we are going to get from NaOH, you can find pH as 14 minus pOH. So, first what we are going to find out is the pOH value, and from that we will find out the pH. So, here we put it as pOH is equal to negative log to the base 10 of the value 0.001, and that is equal to 0.001 can be written as 10 to the power minus 3, okay, and negative logarithm, that is pOH, will be equal to 3. pH 14 minus 3, and the value will be equal to 11. So, you have to remember, from an alkali you will not get directly the pH, you will get the value of pOH, and you will take the expression pH plus pOH is equal to 14, and from that we will calculate the pH value. Next is calculate the pOH and pH of 0.002 molar calcium hydroxide. First thing, we will have to write the ionization, how does it ionize, and only then you can find out the concentration of OH minus. You will have 2 OH minus ions. If I am starting with the concentration of 0.002 calcium hydroxide, calcium ions will be of the same concentration, but OH minus ions will be 2 into 0.002. Got it? And therefore, the pOH should be equal to minus of log to the base 10 of 2 into 0.002, and the value will be 2.3979. Now, how will you find out the pH? pH is equal to 14 minus pOH, and that is equal to 14 minus 2.3979, which is equal to 11.6026. So, we found out the pOH as well as the pH. And last problem is we will have to find out the hydrogen ion concentration if the pH is given. So, the pH is given as 4.699. So, first we will put it as pH is equal to 4.699. But again we know that pH is negative log to the base 10 of H3O plus ions, and that is equal to 4.699. Take the negative sign to the other side, log to the base 10 of H3O plus concentration will be equal to minus of 4.699, and if I have to find out the molar concentration of H3O plus, what we are going to do is we are going to take the log to the other side. When we take log to the other side, it is considered as anti-log. Anti-log of, it is very important, it is of a negative number 4.699. Now, how to calculate that? Here press shift in your scientific calculator and then press log. So, shift and log will give you the anti-log operation. Put a bracket, give a negative sign and enter the number, and the answer will come out as 1.9999 into 10 to the power minus 4, and the unit will be moles per liter, because it is a concentration of H3O plus ions. Once more I will tell you, press the shift key followed by log key, enter the value in bracket, that is you can put it as a bracket and minus 4.699, you will get the answer as 1.999 into 10 to the power minus 5 moles per liter. So, with that we conclude this session. In this session we have been seeing the ionic product of water and the values 10 to the power minus 14, and if it is considered as pKw, the value is 14 itself. Again it is a constant at a given temperature, and at 298 Kelvin the Kw value is 10 to the power minus 14 and pKw value is equal to 14. Then we have been seeing the pH scale, which gives us an idea about the hydronium ion concentrations in a solution, and you can identify whether a solution is acidic or basic, and also the pOH scale, which determines the concentration of OH minus ions in a solution. Thank you.